Hello students, there is a question number 17. It reads, there is a small disk which is sliding on a frictionless horizontal floor and with a known velocity, and this collides head on with another identical disk which is kept at rest on the same floor. If during the time interval tau the first and the second disk cover distances s1 and s2, so distances covered by the two disks over the time interval tau has been given to us. Find possible values of initial velocity u of the first disk as well as the distance between the disk which was initially. So we need to find the values of this. So let's say we got a first disk like this. This is the first disk, and there is another disk, this. Now these two disks are at rest. I mean, like, the second one is at rest, not the both. The first one was given a velocity u, and they undergo head-on collision. Okay, and then after they will be moving. So let's say after tau second, first was observed over here, second was found over here. Let's consider in this manner. Now let's say first is, we are calling it like m1, and second we are calling by m2. So this is m1 first, this is m2 second. Now this first is here m1 and m2 is there, and this duration is this was scenario when t is equal to t naught is 0, and this was when the t becomes tau. That means from here to here it gets converted in the tau time interval. Now in between there has been a collision and all that. Now we know if we consider both as our system, so there is no external forces acting. So for m1 and m2 system, force in the x direction is 0. That means ACM is 0. Center of mass is having 0 acceleration, which further indicates that center of mass velocity remains constant. Now can you find the center of mass velocity initially? Yes, we can find. So what is that constant center of mass velocity? Is going to be like m1. Now the both balls are identical, right? So their masses are going to be equal. So m1 and m2, they are equal. So it's going to be like m1 u1 plus m2 u2 divided by m1 plus m2. If we use this, so m1 is m, u1 is u, m2 is m, u2 is 0 divided by twice m. Basically it gets converted into u by 2. So center of mass is moving with velocity u by 2, and this velocity is a constant. Okay, and how much the time it has taken this? Now if this has moved a displacement x1, so what the question says, this question says like this: this has traveled a distance or displacement in the forward direction, this is s1, whereas the second one has gone this distance, which is s2. So can you find how much the displacement or distance covered by the center of mass is going to be? So we can say xcm, the center of mass displacement or location. So we are considering here displacement. So this is going to be like m1, that is m, s1, that is s1, plus m2, s2 divided by m1 plus m2, that is 2m. This gets converted into s1 plus s2 divided by 2. So center of mass is shifting by this distance, and it is moving with a constant velocity v, and how long it takes? Tau. So can we relate these two? Yes, we can relate. So it's going to be the velocity vcm is going to be equal to xcm divided by time tau. Now let's put the values. So values will say u by 2 should be equal to s1 plus s2 by 2 divided by tau. This will let us know what the u is going to be. So u is going to be basically s1 plus s2 divided by tau. So one answer we have got, the answer about what is the initial velocity. Okay. Now let's come back to find the initial separation. Now initial separation is basically this distance. We need to find the possible values of this. This is L, and Let's say this distance, finally they are having a distance x or something. So we can relate that this distance total is equal to this distance total. So from the figure we can claim, so let me write over here, from figure we will be able to claim that L plus S2 should be equal to S1 plus X. That means we are able to find this L is going to be equal to S1 minus S2 plus X. Now X is the gap between the two. Now, this X here that we are using is the gap between these two, right? Now L is the initial separation. We need to find S1, S2 are known number. Now can we find this range of X? X is a distance between, or separation between the two blocks. So X has to be greater than or equal to 0. So X must be greater than or equal to 0. And it should be less than or equal to, now how much the maximum value of X could be? This block, first block, if it comes at rest at this position, then this will be the gap. That means the gap can be as max as S2. So this must be less than S2. Now since S is an addition, so if we put the X value 0, that means we are finding the minimum value of L. And if we are putting the X as maximum, so we are getting the L maximum value of X. So can we say from here L is going to have minimum value, minimum separation as S1 minus S2, putting X equal to 0. And can we conclude from here L is going to has max value, which is going to be equal to S1 minus S2 plus the value of max X, which is S2. Basically it is S1. If we combine them together, we can say L must be greater than or equal to S1 minus S2, but less than or equal to S1. So this is the possible values of L, that means the initial separation, and this is the initial velocity of first disk. These are the two desired answers, and we got them. Thank you.